Yes. So introduction to organic chemistry. So first of all, in organic chemistry, very important is drawing the Lewis structures. Representation of a small molecules is very important. So in this class, so it is for beginners. Introduction to organic chemistry. So to how to find organic molecules, one is the electronic charge in a clouds, and study the electrons and flow. So very important, how to the flow of electrons are very important in understanding of mechanism of reactions. And so for example metallic lightning. So for example a small metal can save the building because of, so it is attract the so lightning. So that is the importance, and that nothing but electrons. So reactions occurs as a result of a motion of electrons. So we know that reactions occur as a result of motion of electrons. For example, in the following reactions, the curved arrows represent the motion or flow of electrons. So this is the flow of electrons. For example, hydroxide anion, because hydroxide is having 3 lone pair of electrons, so that it has one negative charge here, and methyl iodide. So now the arrow mark indicate that the nucleophile attack on the backside of this one, so that this is this represent the flow of electrons, so that it will form the now OH, the now the electrons are formed in this manner. So again I minus is the leaving group. So central role of the electrons in the following, in the formation of the bonds and influence the molecular properties. So first of all, to introduce, so introduction to organic chemistry, the organic chemistry in 1928, a German chemist, the scientist named Friedrich Euler, demonstrated the conversion of ammonium cyanate into urea. So this is NH4OCN is called ammonium cyanate. It is an inorganic compound. Thermal heating, it gives urea, NH2C double bond O CH3, NH2 and NH2. So NH2C double bond O NH2 is called urea. So now this is the consider as a organic chemistry. So Euler is the father of organic chemistry. So to study this one, organic chemistry occupies a central role in the world. So for example, in various examples you can see that in for example food industry and odor, for example smelling favoring reagents, coloring agents, pharmaceutical industry and pesticides, the paint industry and adhesives, plastics. So these are all made from the organic compounds, and biologically very important DNA, RNA, proteins. So these and all behaves, so their behavior and their functions also determined by the guiding the principles of organic chemistry. So for example, the molecular formula C2H6O, we can write CH3OCH3. So dimethyl ether, its boiling point is 23 degrees centigrade, and ethyl alcohol CH3CH2OH, its boiling point is 78.4 degrees centigrade. So these ethyl alcohols used as a beverages. So there are, so in organic chemistry is very important to study the properties of a molecule, to understand the properties of a molecule. So structure is very important. So in this one, the structural theory of matter, for example carbon is there, carbon is a tetravalent, that's why 4 electrons and 4 sigma bonds are represented here, and nitrogen is a trivalent, and oxygen is a divalent and monovalent. So according to Lewis 1, and everything should be a satisfied octet electronic configuration. So this is very important. Carbon is a tetravalent, so the carbon generally forms 4 bonds, so whereas a nitrogen generally forms 3 bonds. with one lone pair of electron will be there. Oxygen generally forms two bonds with two lone pair of electrons, whereas the halogens like fluoride, chlorine, bromine or iodine, so this hydrogen and halogens generally form only one bond and the remaining three lone pair of electrons are present. So this is the structural theory of a matter. And another one, so how to skill builder. So for example, drawing and all constitutional isomers so that have a molecular formula. For example, the molecular formula is C3H8O, and how can we can write to connect the structure of molecule. For example, now we have to divide, here three carbons are there, so that C and each one having four bonds and one oxygen is there. So we have to, first of all we have to represent individually we have to represent like this, and we have to connect. So now this bond and this bond is connected now, and this bond is connected now, and this bond is connected, so that now there is a bond will be there, and you can see here now the bond is there, and now every carbon is tetravalent, here also tetravalent, and oxygen is a divalent, and additionally here the two lone pair of electrons are present. So this is the finally we can get the skill builder of very important concept, CH3 and CH2 and CH2OH. So this is the representation of the molecular structure of propyl alcohol. So this is the one propanol. For example, you can see this is the two propanol and the CH3 and the CHOH and CH3, and another one ethyl methyl ether. So the molecular formula C3H8O, but now constitutional isomers, one propanol and two propanol and ethyl methyl ether. So that's why, so CH3 oxygen and CH2 and CH3. So this is the very important representation of small molecules of organic molecules. So now we can see CH3, CH2, CH2OH and CH3, CHOH and CH3 and CH3O, CH2, CH3. So how to identifying hybridization? So very important to identify very easily. So number of, for example, how we have to count number of sigma bonds. For example, you can see here 4 sigma bonds is there. So it is a sp3. So if it is a 4 sigma bonds sp3 and 3 sigma bonds, it is a sp2 hybridization, and 2 sigma bonds and it is a sp hybridization. So this is a very simple concept, easily identifying. For example, you can see here 4 sigma bonds is present, so sp3 hybridization, whereas you can see in this carbon and this carbon, so 2 carbons is there, and it is sp2 hybridization. 3 sigma bonds is there, so you can see 1 2 3, and if it is a alkyne, there is a only 3 sigma bond sp hybridization. So each carbon is surrounded by only two sigma bonds, so that now you can see here 2 sigma bonds present. So now how to identify? So sp hybridization, and here this is the sp2 and sp2, and this and all other carbons are sp3 hybridization. So if it is a tetravalent, all are 4 sigma bonds, then sp3 hybridization, and 3 sigma bonds 1 pi bond, so sp2 hybridization, and 2 sigma bonds 2 pi bonds, it is a sp hybridization. So this and all, so the question is that determine the hybridization state of each of the following compounds. For example, you can see this is the now this CH3 4 sigma bonds is there and sp3 hybridization, and now this is the sp2 hybridization, and this is also sp2 hybridization, and you can see these are 4 sigma bonds is there and sp3, and this is sp and this is sp, and so sp3 and sp3. So this is a cyclic system. So now this is sp2 hybridization and sp2 hybridization, and this is sp3 and sp3. So like this, so now this is the sp hybridization and sp2 and sp2. So these are the typical examples of the structural concept of organic chemistry. And you can see here one of the important is that the drug is that nicotin. So nicotin is very important drug, it can be used. So nicotin is important for fungal is an infectional drug. So it is మేము మాట్లాడితే మీరు రికార్డ్ అవుతుంది. It is found in the year of 1940. So you can see this is the nicotin is extracted from the fungus poria in the year of 1940. So this is the sp and sp2 and sp2. So like this is the very important structural aspect of. And bond strength and another concept is bond strength and bond order. So ethane CH3, so it is a 1.54 angstroms. Ethylene is the CH2 double bond CH2 1.34 angstroms, and alkyne so is sp hybridization 1.20 angstroms, and its bond length so 368 kilojoule per mole, and whereas the ethylene 632 kilojoule per mole, and is ethane 820 kilojoule per mole. So now ethane, so now because of it is sp3 hybridization, so bond angle is 109.5 minutes, and ammonia is a trigonal pyramidal geometry, its bond angle is 107. So pyramidal indicates the compounds is shaped like a pyramidal. So now the H2O is there, angular in shape, its bond angle is 105. So these are the trigonal planar geometry of different molecule. For example, BH3 and BF3, so its bond angle is 120, hybridization is sp2 hybridization, and similarly it is a beryllium hydride. So the beryllium hydride is sp hybridization, and it is a linear structure. So these are the different, for example, so predicting the skill, learn a skill, that is the predicting geometry, and it's hydronium ion H3O plus sp3 hybridization and tetrahedral geometry, and BF3 sp2 hybridization and trigonal planar ammonium cation, so ammonium sp3 hybridization and tetrahedral geometry, and methyl chloride sp3 hybridization tetrahedral. Carbocation, so it is a carbon is bearing positive charge, so it is a sp2 hybridization, and carbon bearing negative charge, it is a carbanion, so it is a sp3 hybridization. So then comes to the another one, because ammonia, because lone pair of electron is there, and hydronium ion, it can give the proton, so it will form ammonium ion and H2O. So similarly, for example, acetone, the dipole moment. So another concept is that dipole moment, also very important. So dipole moment, also another important criteria. For example, so acetone CH3 C double bond O CH3 dipole moment is 2.69, methyl chloride 1.8, H2O 1.85, methanol 1.69, ethyl alcohol 1.66 dB, and so this one is diethyl ether 1.15 dB, and so diethyl ether. So these are the once the molecule have symmetrical like carbon tetrachloride or dichloro 1,4 dichlorobenzene, the dipole moment is 0. So what we learn here skill, you can see that methyl so carbon dioxide does not have a net dipole moment because of its a linear structure, and we can from the following the molecule, the dipole moment we can identify, because tetrahydrofuran dioxane 1,3 dihexenone and 1,4 di. So because so this analysis and trans, so now this is the trans is dipole moment is 0, and this is also dipole moment is not equal to 0, and diphenyl ether, so it is a volatile organic compounds, its also dipole moment is not equal to 0. For example, dipole moment, for example 1,4 dichlorobenzene is the dipole moment is 0. So another one, hydrogen bond. So hydrogen bonding also another important very concept. So what is mean by hydrogen bond? The term hydrogen bonding so is a misleading. So it's not a hydrogen bond is not actually a bond, but it is a specific type of a dipole interaction. So when a hydrogen atom is completely is electronegative atom usually connected to oxygen or nitrogen or fluorine, so that it will be bear so positive charge of that particular carbon. For example, OH2 is there, so oxygen and hydrogen. So oxygen is more electronegative, so that it gets the negative charge, and hydrogen is a positive charge. So there is a positive and negative dipole. So there is a hydrogen bond interactions between molecules of water. So there is again intermolecular hydrogen bond and intramolecular hydrogen bond. You can see here ethyl alcohol, its boiling point is 78 degrees centigrade, whereas the methoxyethane, so no hydrogen bond, so that its boiling point is 23 degrees centigrade. Its boiling point is very low. It's indicate that it is a hydrogen bond. And similarly, so trimethylamine, so trimethyl ammonia is the 3.5 degrees centigrade, its boiling point. So now methyl amine, so now it is a free hydrogen is there, it involve hydrogen bond. So now 37 boiling point. Ethylamine, so propylamine, its boiling point is 49 degrees centigrade. Nothing but it's even though the same molecular weight, but showing that higher boiling is because of hydrogen bond. So increases the strength of hydrogen bond, there is an increase in boiling point of the molecules. And here another one. So now you can see increasing the catenation, the boiling point also increases. C4H10 0 degrees centigrade, C5H12 pentane 36 and hexane 69 degrees centigrade. So even the branching is increasing, the boiling point is decreasing. So pentane 36 degrees centigrade, 2 methyl butane 28 degrees centigrade, and 2, 2 dimethyl propane, so 10 degree centigrade. So this and all, so once so increasing the carbon chain length, you can see increasing the a carbon homologous series, the boiling points also increases. So compared to, you can see here, so diisopropyl is there, and so even because of this is a straight chain ethers are higher boiling point, but here 6 carbons is there, here 5 carbons, so 6 carbons is higher boiling point. And alcohols are higher, straight chain alcohols are higher boiling point than branched alcohols. Then alcohols are higher boiling point than ethers. Can see diethyl ether compared to butanol alcohol is the higher boiling point. And for example, this is one example. So epoxide is there and chlorine is there, reaction with sodium hydroxide. So there is a this product can be expected. So because so phenol react with sodium phenoxide, so that once the cleavage, there are 2 types of products are expected. So this and all, so now the benzene is sp2 hybridization, and you can see it is a cyclic ring and sp2 hybridization. So these are the important structures of a different. So another molecule, for example, very popular Michael Jackson drug 2019, so propofol. So for example, this is the a compound, and it's a dangerous of the human health. So molecular representation, Lewis structures, so and so we have to represent like this.